Hello, today I will discuss about singular value decomposition, and we are calling it as SVD. It is a very important tool and widely using in machine learning for dimension reduction and many analysis purpose also. And this is the program which I am covering for my undergraduate student at IIIT Dharwad. And let us start first topic I am going to cover today. Basically the topic which I will cover, because singular value decomposition is very much related to eigenvalue and eigenvector. I will tell you the importance of eigenvalue and eigenvector. If you see, I am simply writing SVD. What SVD can perform? There is matrix A. We can decompose or factorize. We call matrix into three parts: sigma and V transpose. Right now I am not writing the dimensional matrix. Let us suppose it is M cross N. Okay, I have decomposed problem into M cross M. Then you have N. This is actually eigen value, and it is diagonalized matrix, always sigma 1, sigma 2, sigma n, and rest of the term will be 0, 0, 0, which I will cover later. Don't worry, just I am giving the feeling how you can understand the things and what is happening. Okay, so the dimension I am considering M cross N, and this is my another vector N cross N square matrix. So this is my left singular vector. Okay, corresponding each eigenvalue there will be one vector which is u, which I will perform in later. Let us say u1, u2. So corresponding sigma 1 there is vector u1, corresponding sigma 2 there is vector v2, and similarly we will have v1 and v2 transpose also in this direction, which I am going to. So if you see this portion, what is happening? I have decomposed the problem into three portions. Okay, and about discussing about more, let me start giving you one small input on screen. Okay, now let us start with a small problem, and then you better understand, and then we will cover more mathematics and applications part we will cover. Let us, there is matrix A. As you told, what SVD is doing, it is decomposing this problem into three: U, sigma, V transpose. Is matrix A. The dimension is M cross N. Then here you have U. Initially the factor of U is dimension I am writing M cross M. Then you have a matrix sigma which have dimension M cross N. Okay, and then you have V transpose. This is your V transpose. This is another vector, and the dimension is N cross N. This is we call eigenvalue. The importance of eigenvalue I will tell you, but all the data in the animal sigma 1, sigma 2, but I will represent it this matrix like sigma 1, sigma 2, sigma n. Okay, M cross N. So it will be M. Okay, the values are M, and each is representing one eigenvalue, eigenvalue 2, eigenvalue 3, and this way I am going eigenvalue M. It should be greater than 0. Okay, always in decreasing order of series. It used to tell principal axis. Okay, and let us come here. This is left singular vector. This is right singular vector, what actually it is corresponding. There is a u1 vector, the u2 vector. This way you have up to un vectors, m column. Similarly, you have sigma n values. In this way, you have v1 transpose, v2 transpose, and in this way you are going up to how many rows? vn transpose. Okay. So always these are the positive values and greater than 0. It is telling principal axis. What is principal axis? Let us consider this axis, and this is suppose science movies. I am considering one person who is watching science movie, and this is art movie. Okay, I asked to give the rating person. The person 1 has given rating 1 to science movie, okay, and 2 to art movie. 1 is corresponding for very good interest in the science movie and very less interest in the art movie. Let us consider it is a scale of 1 to 5. Recommended system like 1 is very good and 5 is very less or poor interest. Another person, some people are watching art movie very greatly, some people have affection for the science movie very much, so they are giving 1 corresponding this one. You will say this is the data of different user view. As I similar matrix is there is person, and this is movie m1, m2, mn movie. Let's suppose these are science movie, this is art movie, and then person. I will describe this in the later, but this is some initial portion which I am covering. So if you see here, you will find, if you see this direction, generally it is like ellipse. You will find in this direction maximum data is projected. If you take the variance in this direction, you will find variance maximum. Variance is telling the more information it is telling. If more variance, then suppose this is your u1 vector, modulus is 1, that means orthonormal, the magnitude is 1. What is this orthonormal? If the magnitude of vector is 1, which I will again describe. Okay, it is just telling direction. Okay, if I will multiply sigma and u1, it will giving the vector sigma 1 and u1. This is first principal axis because sigma 1 has highest value. Then we have sigma 2 also. Then let us change my pointer of color. I am considering to make the clear distinction. I am considering now this is another x. This is sigma 2 and u2. This is another orthonormal vector. Orthonormal vector, this is the beauty of orthonormal, this is always 1. That means the magnitude is 1, u and u transpose will be 1. So in this way u transpose equal to u inverse. These are the property of orthonormal vector, which is just telling the direction. Okay, and greatly it is impacting you. Then let us consider one third color vector, which is telling you the third dimension. Suppose there is three eigenvalues, corresponding 3 eigenvalues, there is 3 eigenvectors. Okay, now mostly populated data here. What I am doing, I am considering this direction. This is sigma 3 and v3, u3. Okay, so 3 eigenvalue corresponding. So it is telling in which direction maximum data is spread, then second maximum, and third. This is telling 3 principal axes. You know, PCA principal component analysis, PCA is principal component analysis. These things are telling you the topmost axis along with the maximum data is distributed. So in this case, we are considering top 3, just maybe 0. So in this case, I will not consider this one, and that's why it is helping you to reduce the dimension. Corresponding this one, this is vector. Corresponding C2, this is my column vector. This is my row vector corresponding this one and this one. Rest value will be nil, which I am not considering. This I will greatly explain later. Okay, so let us go a little bit ahead. which this already I described. Now I will tell one small things which I missed to tell you that time. Yes, come there, come this portion. U is telling rotation, which I will cover later. Just understand sigma is stretching, and this is again rotation. So this was initial things already I described. Just focus on this portion. This is m cross n, and eigenvalue is this one. Eigenvalue, top eigenvalue I will select. So this is dimensity reduction, you can see. Okay, now let us go for the slide. Now coming on the point which I was telling, already something I have described, but after that I will tell you some mathematics detail. If you come into this portion, you see science movie and art movie already I told. This is the person who is watching. These are 5 persons which has opinion. This is the movie rating. Then you have art movies, 2 art movies, Jolly LLB1, Jolly LLB2, and suppose one movie which I given I am Hera is science movie. So if you see here, you will find person 1 is giving 1 to Jolly 1 and person 1 is giving 1 to Jolly 2. That means person 1 is interested in more in art movie and person 1 is not interested in the science movie. Similarly, if you see there is some bias circle, if you find these 3 person has great interest in the art movie and last 2 person have great interest in the science movie. Okay, so corresponding this one, if you will see, coming on this one, this is my eigenvalue, one eigenvalue, second eigenvalue, and third eigenvalue. If you see, first eigenvalue is 1.9, second is 1.2. so 1.9 is because mostly people are interested, that you see 3 people are interested in art movie and 2 people are in science movie. So corresponding this one, eigenvalue is max 1.9, then second. So this is my axis corresponding art movie eigenvalue, and this is corresponding to science movie. These are the vectors which is I am considering u1 and u2. This is my sigma 1 and sigma 2, and corresponding this one there will be value. So this is telling you how person is related to concept and movie. This is telling the strength of concept, and this one. So let us go more in the depth of linear algebra, okay, which I am going to cover. Again, I am going to open the slide, and this is very essential part to understand this one. Here, matrix operations. What is matrix operation and what is eigenvalue? Suppose I am taking one vector x equal to 2, 3. Okay, and I am taking matrix. What matrix can do? See the beauty of matrix. I have considered matrix 1 0 0 1, and I will tell you by this I will derive. Generally we used to find a lambda I equal to 0. This is we do for to find the eigenvalue. Here you will this is my eigenvalue. Okay, so let us once again change the color of pointer. Now come, if matrix is A, so if you plot this one, the vector x, always axis vector is pointing away. This is suppose 0.1 and 0.2. This is 0.1 2 3 4 5 6 7 8. Okay, then if you represent 2 and 3, okay, then I can change the color, and this way let us make it interesting. This is my vector x 2, 3. 2 comma 3. Okay, if you see the magnitude of this one, we call it equivalent norm or base 2. I will calculate root from 0 0 you are considering, that's why 2 minus 0 square, least square square, and the root 3 minus 0 square, you are getting minus 13. This is the strength of this. Okay, now if you are multiplying with matrix, let us have 4 and 4 and 2 and 2, you can consider that means it is 2 1 0 0 1, and we can say that it is alpha 1 0 0 1. Okay, alpha here is 2. What will happen if you multiply matrix A with the vector X? We are doing 2 0 0 2, you are multiplying with vector 2 3, you are getting the value 4 and 6. That means, can I write this one equal to 2 into 3? This is multiplying same vector with the magnitude 2. So this is we call sigma or eigenvalue. So now if I will again going to change the color, in this case if I now I am extending it is, and the magnitude is now 4 and 6, and I am multiplying with the 2. This is corresponding to 4, this is corresponding to somewhat 6. Okay, so what beauty of eigenvalue? One operation, this is stretching. So alpha 0 0 alpha, let us say it is A, is stretching matrix. So in this case it is playing the role of multiplying 2. That's why whenever you are going to consider eigenvalue, A minus lambda I equal to 0. If it is of 2 cross 2, lambda is always schematic. If 2 cross 2, this is lambda I 2 cross 2. That means same factor, by this factor you are multiplying. Here is lambda factor 1 0 0 1 is any matrix 2 0 1 2, suppose lambda would be 1 2 3. Then in this way you will find some multiple of the vector xy. So this is the beauty of eigenvalue, and this is corresponding your first principal axis, first eigenvalue, then second eigenvalue. Okay, so matrix is helping you to first operation is stretching. In second chapter I will explain you what matrix again can do. Matrix, let us take another matrix equal to 2 1 1. Consider vector x equal to 1. What matrix will into x you are getting? In case of eigenvalue you were getting this one. Okay, when A was 1 0 0 1 or 18 multiplied by alpha. So as we multiply with 2 0 0 2, x is this one, you will find A is 2 0 0 2 with x is 1 2, you will get 2 times of 1 and 2. So simple vector x, this is the property of eigenvalue. Okay, and this is eigenvector corresponding this, but this is only stretching. Can I perform something? Yes, we can do. If you want to rotate matrix, you can do cos theta minus sin theta and cos theta. Let us assume theta equal to 90. It will rotate some vector 1 2 into 90. What is the value now? Cos 90 0 minus 1 1 and 0. This is now A. Let us do A into x. What is happening? 0 minus 1 1 0, you are multiplying with 1 and 2, you are getting 0 into 1 minus 2. So this is 2 cross 2, 2 cross 1, you will get 2 cross 1 matrix, and this is 1. If you realize this one, we'll find something. Let us this is my 1 and 2, so my vector is this one, x is this one, 1 and 2 it is telling. Okay, now what we are getting, 1 and 2 minus 2 and 1, it is 90 degrees. So you have rotated this vector by 90 degrees. So another thing is rotation. First rotation and stretching. This matrix can do that. And you can combine both. So any vector x1, x2, let's suppose this is x, multiplying with matrix, I can perform these basic two operations, rotation and stretching, which is covered here. Okay, if you see this portion, what is happening? Stretching. Initial position is x and y. I multiply 6. So whenever I am taking matrix in form of A equal to C0, C0, that means how I can write C I 1 0 0 1. It is going to stretch. You can see this is rotation, which I have already done for 90 degree. When theta equal to 90 degree, then it is going to rotate, and it is, you can see here, this is my rotation, and rotation matrix was 90 degree. Okay, you can get the reflection. Similarly, you can get reflection and projection. Projection I will explain greatly, and the reflection is that you see yx and the reflection is x. That means you have changes 45 mirror image. What is projection? I have to explain. Projection. Let us consider this two coordinate system. Vector is here, root 3 is the magnitude, root 13 is this one, this is my x vector, this is another my y vector, and suppose this is science movie, this is my art movie, and this is rating the person, which again this is data 1, data 2, data 1 is corresponding to our science movie. Okay, and this is, you can consider the feature space of, this is one eigenvalue correspond, second eigenvalue you can consider, this is correspond to science, this is correspond to art, and this is suppose movie Jolly LLB, and this is suppose Hera-Pheri, and I have given the rating this one. So how I will project this one? The projection is telling that just take one perpendicular on the axis, and it is called z dot. It is projection. It is always giving the strength. This is P. So P dot greatly the positive value of magnitude. This is equivalent known of y. So always dot product is giving this one. So this is the projection of this one. If we are taking y dot x, in this case, the first thing is just tell the perpendicular on another axis, and this is the projection of this one. Okay, so this is the dot. If both are orthogonal, I will find that x into x transpose will be one orthogonal vectors. Okay, so in this case x transpose will become x inverse, which I will use later. What is orthonormal? U, for which value is the orthonormal norm is 1. So u is, this is just telling the direction, and if you are multiplying mu and b, it is giving to highly magnetic. So this is the projection. Okay, in this case you can see that if you, this is the, which is closely near to the Hera-Pheri, that means art movie, and this is art movie, and this is science movie. Suppose what is happening, if you see the projection on this one, you will able to find that data is falling in which has greater impact, either this value and this value. This is corresponding to concept of science movie, this is corresponding to art movie. So it is telling that the more eigenvalue, there is two eigenvalues, sigma 2, sigma 1 and sigma 2. This is sigma 1 and this is sigma 2, u2, and this is u. If it is has higher value compared to this one, then it is falling in the art movie. If it is higher value, sigma 2 is higher value, then it is falling in the another category. So this is the projection. If you see this, let us change the color, otherwise it will be not visible to me to explain. Now you see this one. This is the projection. This is xy. You have projected x and y made the 0. This is basic mathematical operation. As I discussed, you concentrate here. X transpose y, that means 2 vector x transpose y. Suppose x is 1, 2, y equal to 2, 3. If you want to multiply, obviously what you have to do? You have to take x transpose y, then only you can do 1 close 2 and 2 close 3. You will find one singular value. If it is 0, then means both are 90 degrees perpendicular. This same concept they have written. If it is 0, then if it is less than 90 degrees, then the inner product will greater than 0. If it is greater than 90, then inner product will be less than 0. Okay, this is simple Pythagoras problem. This is magnitude of this one, magnitude, and the sum of this one is this. This already I explained the concept. This is, if you see, stretching factor. This is by the sigma, which is eigenvalue, and same thing is there. So I'm not going to waste much time here. Now let us go for beautiful property of, as you are aware of now, eigenvalue, matrix operation, dot product, inner product. So understand, as we told, this is decomposition, m cross and u, m cross m, sigma m cross m, and v transpose m cross. This is, I told, rotation and left singular vector, left singular vector. This is my eigenvalue, this is my right singular vector. Okay, this is again rotation, and this is your stretching. Let's suppose that I have initial vector v1 and v2, both are 90 degrees. Okay, if I am applying directly, I cannot apply, but entire transformation A form will be here. That's what I am doing. U, what it is doing? It is not stretching, it is just rotating the this one, rotation. So coordinate has changed. Now I am multiplying with sigma. What it is doing? It is stretching, and in 2D plane it is circle or and 3D sphere, and more higher plane it is hypersphere. So it is stretching now. So you will see, this is sigma 1 into u1, sigma 2 into u2. Okay, these are now stretched. u1, u2 are orthonormal. That means, so just if you are multiplying with sigma and this is scalar quantity, you are multiplying increasing matrix. You say now this is your rotation. It has stretched, sigma has stretched it, and it has converted ellipse shape, and then again you are performing V transpose, which is again rotation, and you can see that it has rotated like this. Sigma to 0. So this is anti-transform what A is doing. This is geometrical representation. So by matrix manipulation, you can traverse anywhere, you can move anywhere except null space. Okay, let us go more in depth. Okay, this already I have covered. This is sphere in the, okay, and stretching plus rotating. What A is performing? Both stretching, rotation, and stretch. Rotation, stretching, and rotation. So finally you got, this is first principal axis, second principal axis, third principal axis, along with the data is mostly distributed. Okay. Now understand the important concept of SVD, which we'll use for Fibonacci series calculation also. First, as we told, this is matrix A, m cross m. Then we have transform. This is m cross m square matrix. I told This is u1, u2 up to um vectors. Okay, this is my u left singular matrix. Then to same height m cross m. This is my sigma matrix. We actually just keeping sigma 1, sigma 2, sigma 3, sigma diagonal matrix. Then you have on the left singular vector v1 transpose, v2 transpose, vn transpose, and cross m. Okay, and always this is sigma 1 is greater than sigma 2. This is always decreasing order of sigma. I told only few are positive value, rest we can neglect and nullify also. So what is happening now? How it is beautiful, how the diagonal concept of matrix will convert. This is the rectangular matrix I can convert into diagonal by this one, and this is helping calculating the factorial. But before this, what is this, how we are doing? As I told, only I am considering some top value. Let's suppose I am going to sigma r. Okay, so we are considering only up to this value, rest value are null. So corresponding this one I am getting this one, corresponding this one I am getting, corresponding r I will get ur. Similarly I am getting, so now the dimensity reduction, rest value I nullify, you will find that more than r all the value I will nullify. Similarly more than r all the value you will be nullifying. That means these value are deleting. Okay, so what you have done, first r value is here and less and minus r is null, because corresponding their eigenvalue is 0, so I am not considering these vectors. So dimensity had reduction here, and this is the rank of matrix and independent vectors, rank of matrix. Okay, and simply here now this is r and minus r you are deleting. Simply this is r and m minus r you are deleting because m is 0. So after transforming, what will happen? The matrix U will become m cross r, which was actually A was m cross n. Then it is becoming only topmost values, diagonal r cross r, and then you have r cross and matrix. That means top r column we are selecting. This is u1, u2. This is sigma 1, and suppose you have only two values, sigma 1 is greater than sigma 2. That means this is my science movie concept, this is my art movie concept. So corresponding this one vector is going to be impact more, than second value vector is going to impact after that. Similarly these are corresponding left singular vector and right singular vector. Okay, so I will give perfect example here. So once you have this diagonal matrix, what beautiful things, which I am going to cover in next slide. First, let us take example of unique cases. F not equal to 1 and F1 equal to 1. This is the base condition. I can place in the vector. Can I write equal to 1? And if you want to calculate F2 equal to F0 plus F1, this is 2 because it is always 0, 1, 1, 2, 3, 5, 8, 13 this value. Then you have to keep the value of F1 also, because to calculate F3 you need F2 plus F1, which is the combination of both. This is again 3, and then you have to return the value of 2 because you need to calculate F3 plus F2. That means summation of both. So you are storing both the previous value, you are getting 5 and storing F3 equal to 3. In this way you can write Fn equal to Fn minus 1 plus Fn minus 2, and you have to store the value of Fn to calculate the Fn. So if I write in terms of matrix Fn equal to Fn minus 1 equal to 1, 1, 1, 0, can I write? And you can write Fn minus 1 and Fn minus 2. Okay, then here matrix A is 1, 1, 1, 0. It is okay if you are finding F10, but if you are finding F100, then it is very different, because what is happening, Fn equal to Fn minus 1. If you are writing 1, 1, 1, 0, 1 1. How you will solve? And you will fn minus 2, fn minus 3. Till when I will do? Till I will not find the base condition. Because what is the, how this will work? You know, fn equal to fn minus 1 plus fn minus 2 is when n is greater than 2, and if n equal to 1 or n equal to 0, in this case fn will be 1. Okay, so that's thing. So can I write fn equal to fn minus 1 and power of n time 1 1 1 0 power of n time, then I am writing f naught, f1 and f naught, as I know the base condition value, and this is 1. But how it is difficult to compute a equal to 1 1 1 0 power n. If here the benefit of diagonal, if diagonal matrix, let us suppose D sigma 1 0 0 sigma 2, if you have to find the n power, you just need to take the nth power of this one, you will get easily. So we have to convert somehow this one. So we used to do this using the SVD, which I will cover later. So already most of the portion I have covered here. Okay, one more concept is living here, which finally I will cover now. As I told, a equal to u sigma b transpose, this is already this one. So can I write a equal to like this, and there is two vector u1 and u2, then you have sigma 1 and sigma 2, then you have b1 and b2. You can write multiplication of this one like if n vector I equal to 1 to n sigma I ui and bi transpose. When n time you are doing same thing. If n eigenvalue, if 2, then it is simply you can divide u1 sigma 1 and b1 plus u2 sigma 2 and b2. Okay, but eigenvalue is 2. This is great impact is going to happen, and with example I will try to explain the things. Okay, so this is all about this one. Now how it is related to your eigenvalue. As you know the concept of eigenvalue, eigenvalue is great impact like ax equal to lambda x with vector x. But in this case what I am getting, a equal to u sigma v transpose. Okay, let us take a into v. What we are getting, u sigma v transpose into v. This is u, which is not actually, there is different vector, u and v are different vector. Okay, so to get the eigenvalue, what I will do, a into a transpose, can I take what is a, u sigma v transpose, and I am multiplying u sigma v transpose. Then what I will get, a transpose, a b transpose always will be b transpose into a transpose, u sigma v transpose, and it is going to be v sigma transpose u transpose. Then both are, I told, orthogonal matrix, so multiplication is 1 iota I, so it is going sigma transpose now and u transpose. As both are diagonal matrix, so u is going to be square and u transpose into a transpose. Now multiply with this with the left singular matrix u, what it will be, u sigma u transpose and u, which is again I, so u sigma square. You see from here, this is how it is related, ax equal to lambda x, so lambda equal to sigma square. So in this way I can write sigma I root sigma I is the my eigenvalues. Okay, and this is left singular vector, and if you want to find right, so what you will do, a transpose a, you will get v sigma transpose u transpose, and then what is a, u sigma v transpose, this iota, you are getting v sigma transpose v transpose, sigma into sigma transpose, this is sigma square, v sigma square v transpose, and this is a transpose a. You multiply both sides was v, what will give, v sigma square v transpose v, this is again I, so v sigma square, again you can see that you can get the eigenvalue. So this is how it will concept of SVD is helping you to find the things. Okay, once you have this one, how you will apply matrix. This is the things, this already I tried, same thing, this concept already I told you. Now let us take one very good example. Okay, so that the concept will become clear, and then I will finish with a few. There is matrix A, which is P1, P2, P3, P4. This is movie 1, movie 2, movie 3. Okay, these three movies belonging to art movie. This movie is belonging to science movie, sci-fi. Okay, person P1, P2, 3, P5. You can consider more to sample. And you are giving rating between 1 to 5. If person watching finding very good and loving the movie, we are giving 1 rating. If it is not that much interest, then we are giving. So suppose person first has given, second 2. Okay, then 0, 0 they are coming, and 5 and 0, 1, 2, 0, 2, 3, 0, 4, 3, and here 1, 2, and 3. If you can say that person 1, 2, 3 is greatly influenced by the science movie, art movie, and these two are greatly influenced by the science movie. If you see, they have very less interest in science movie, so clearly you have divided matrix into 2 parts. Okay, similarly if you decompose, you will get U sigma V transfer. You are supposed to get, suppose you are getting 0.6, 0.7, 0.8, 0, 0, 0, 0, 0.1, 0.7, 0.4, one more column you are 0.2, 0.3, 0.5, 0. If you see this one, and there is one you are getting 1.9, 1.2, 0.6, 0, 0, 0, 0, 0, 0. Then you are getting V transpose 3 movie M1, M2, M3. You are getting 0.9, 0.7, 0.6, 0, 0.2, 0, 0.1, 0.2, 0.7, 0.8. Then you are getting some random value. This we consider. Now again I am changing the color. Okay, what I am doing now, I am telling you the beautiful concept of how you can utilize here. If you see, this is person P1, P2, P3, P4, P5. You see, this is first concept 1 and concept 2. Okay, third I am considering the noise, so I am removing this one from here and this one, because there is 2 concepts. This is your art movie, because mostly people are watching art, so art has great influence, and then less people are watching sci-fi, and who are watching, these are the strength of person, strength of concepts, which concept they are like. So you can see that sigma 1 is greater than sigma 2 is greater than sigma 3. Sigma 3 I am not considering, I am considering first 2, so I have reduced the dimension from 3 cross 3 to 2 cross 2. This is r equal to 2, this is n. In sense, corresponding sigma 1 I have this vector, corresponding sigma 2 I am getting this vector, and corresponding this one I am not. This is noise I am getting. Similarly I am getting corresponding this one, corresponding this to this. You will see first 3 people are mostly interested in art movie. They have great impact in art movie, and they are getting 0, 0, so they are not interested in the sci-fi movie. From there you can draw the conclusion. You can see the last 2 person are greatly influencing the art movie, and they are not, because the art movie, this is art movie vector, this is art first, and this is sci-fi. So they only 2 are watching very interested with the sci-fi, and in this case this is telling you people to concept relation. How people are liking the concept here, custom, and this is moving to movie to concept. You will see first 3 users is greatly influenced by movie 1, and last 2 users is greatly. Okay, now there is, you have 2 concepts B1, both are perpendicular B2, that is corresponding sigma 1 U1 and sigma 2 B2. Okay, and you have projection that movie 1 and movie 3. one person is coming, you have to find which class belongs. So you simply take the projection like this. I'm taking one query. Query is that I have given 1 0 5. That means you can see that it is strongly belonging to art movie concept. This is M1, M2, M3. It is greatly influenced with this one and very less. If I will multiply with u into u, this one, what I will do, I will get vector, because this is 1 cross, this is 1 cross 3, this is 3 cross 3. What I will get? I will get 1 cross 3, or I have reduced this one, only R I am selecting. So what is now the answer? I have removed this one, this is 3 cross 2. 3 cross 2. So you will get two value, 1.25 and 0.7. Okay, you can see that this person is belonging much interest in 1.25. That means this is corresponding to art movie, as it is giving more. Now let us under query Q2. I am giving 2, 2 and 0 to this one. In this case, if you multiply with the left vector u, this is 1 cross 3 and 3 cross 2. I am getting 1 cross 2 cross 2. In this case, you will get again 1.9 and 0.6. You say this is higher value, so again you are belonging to same category. Now let us take query 3, in which 0, 0 and 0. In this case, if you multiply with the u, this is I'm finding the how person is liking the movie, that's why I'm multiplying with the u vector. Otherwise, if you want to consider how movie is belonging to concept, then in this case this is movie to concept ratio, movie to concept ratio, and this is person to concept ratio. Okay, person to concept ratio. Okay, in this case if you multiply, you will find the vector 0.7 and 1.9, which is more for the science. So you can verify the things and you can use any type of data set. Okay, this is all what eigenvalue will tell. Similar thing I projected. This is, let us take very wonderful example of rabbit. There is one rabbit and it will become mature in 2 months, and either you can say one pair of rabbit, because rabbit is able to reproduce without any partner. After 2 months it will become the mature, and okay, and after after 2 months it will give the one baby rabbit. We have to find after 12 months how many rabbits will be there. So this is very good example of Fibonacci series. You can refer. Initially there is, I have to find after 12 months how many. 1 month, 2 months, 3 months, 4 months, 5 months, 6 months, 8, 9, 10. After 11 months I have to. In first month I have rabbit 1. Second month this rabbit 1 only will be here because it is still immature. In third month it is going to become mature and it is going to give the one baby rabbit R2. Next month, each month from next 3 months after second month, it is going to produce each month one new rabbit. So next month 4, I am carrying R1 and R2. R2 is still immature, so I am not, but R1 will give birth to new rabbit R3. Next month you will see R1, R2 and R3 will be as it is. Sorry. Now R1 will give birth to R4. R2 is now mature because it has completed 2 months, so it is going to give R5, but R3 is still mature. So you will see there is 1, 1, 2, 3, 5. Let us consider R1, R2, R3, R4, R5. R4 and R5 both are not mature. Okay, R3 is mature, so R1, R2, R3 will produce 3 more. 6, 7, 8. This is simple Fibonacci series. If you see 1, 1, 2, 2, 3. So after 12 months, simply Fn equal to Fn minus 1 plus Fn minus 2 when n is greater than 12. So F12 equal to F11 plus F10. So in this case, problem is that you have to calculate Fn equal to Fn minus 1, which is in this case F12, and F11. It will be multiplication of 1, 1, 1, 0 is for n, and F1 and F2 I2 by SVD. You can consider the sigma, which is diagonal matrix, and in this case U sigma V transpose. If you want to calculate A square, you just need to take square of sigma AQ U sigma Q, which is diagonal matrix. So in this case you just need to, suppose I got A 0 0 B. In this case if I have to calculate n, what I will do, a raised to power 10 and b raised to power 10, and simply I'm multiplying u here, v here, and then we have vector 1 1 which is corresponding to this one. We will multiply, we will get the value. This is all about of singular value decomposition and great intuition which I solved. Here I would like to thank you for watching and keep giving your feedbacks. I will come with more group videos. Thanks. Great. Thanks for watching.